Assalamualaikum and very good morning. My name is Muhammad Aminuddin bin Piramli. I'm from Faculty of Mechanical and Automotive Engineering Technology, University Malaysia Pahang. I will be presenting on title Transient-Based Leak Detection and Monitoring of Water Pipes using Complete Ensemble Empirical Mode Decomposition. Okay, as introduction, non-revenue water is the most popular term in water industry. This is because NRW is the main problem they have to face every year. NRW basically is the water loss in the process of distributing water to the consumer. And non-revenue water basically divided into two problems, that is physical loss and also commercial loss. In physical loss, it contains two major parts, that is leakage and also pipe burst. For commercial loss, it includes inaccurate meter reading, service maintenance, and also water theft. Many states recorded a high NRW level exceeding 40%, such as Pahang, Sabah, Negeri Sembilan, Kelantan, Kedah, and also Perlis. These states are also recorded in high physical loss, which is more than 20%. Okay, the chronology of leak detection technology begin from 1850s by only using manual sounding. However, technologies in this field develop from time to time in order to overcome pipeline defect. The latest technology of leak detection is by using smart ball that been developed on 2008. This equipment widely used by water industry, but it high in cost. Issue on all this technology development are mainly too expensive, high labor cost, less accurate, got a limitation access, require interaction of skilled and expert user. Okay, we move to problem statement. Main problem in this field is the high water loss or non-revenue water along the water distribution system that caused especially by leakage. Current leak detection technology really high in cost of the equipment and also need to be handled only by an expert. So this will also cause high labor charge. The problem also in the accuracy of the detection. The current technology used cannot locate the accurate position of the leak. Problem also lie in the signal processing method, that is EMD. The problem is the mood mixing that always occur due to the high level of noise contaminate the original signal. Okay, the objective of this paper is locating features position along the water pipes by using combination of complete ensemble empirical mood decomposition and also Hilbert Transform method. Okay, Hilbert-Huang Transform. Hilbert-Huang Transform basically the combination of pre-processing and post-processing method in one process. It is contain empirical mood decomposition and Hilbert Transform. HHT is mainly used in non-linear and non-stationary signal and can use to extract information from a signal. This method theoretically based on empirical. The problem of HHT is contain EMD method that function to decompose signal. However, EMD is not too stable to process the intermittent signal and way too sensitive to noise. So this paper proposed CEEMD as replacement of EMD method to overcome the mood mixing problem and computational efficiency. Complementary Ensemble Empirical Mode Decomposition (CEMD) method. This method mainly focused on improving original decomposition method, that is EMD. This next generation of EMD ensure decomposition process as well as EEMD and can reduce the reconstruction error. It is also enhanced version with a more robust design to overcome mood mixing problem. CEEMD method implement a particular white noise at every stage of decomposition process. This is the laboratory scale test rig for leak detection experiment. It is contained of 160 meter of medium density polyethylene pipe, high pressure pump, fire hydrant as a point of analysis, solenoid valve, and also pressure sensor that attached to the fire hydrant cap. This shows the detail of fire hydrant cap as the point of analysis. The piezoelectric pressure sensor and solenoid valve attached to the fabricated fire hydrant cap. Solenoid valve will create a water hammer and transient signal will pass through the pipeline. The sensor will capture the signal that contain all information along the pipeline. Here show the signal of the raw data captured using pressure sensor and plotted using MATLAB software. As we can see, the raw data only shows signal that contaminated with variation of noise. The peak in the signal show the opening and closing of solenoid valve that cause pressure drop inside the pipeline and at the same time will generate a transient signal. This signal provides no information of the pipeline network. The true signal hidden inside the contaminated raw data. This raw data need to undergo decomposition to classify its signal. Decomposition method proposed in this paper is CEEMD. So we can see here that the raw data now divided into several components of intrinsic mode function, or also called as IMF, using CEEMD. From here, we can eliminate the undesirable signal within the raw data. Basically, level 1, 2, 3, and 4 of the IMF component only contain noise with the high amplitude. Meanwhile, level 8 and above only contain basic response and also a residue. So, we will concern only on IMF level 5, 6, and 7 where the true signal lies. The selected signal will be used to undergo instantaneous frequency analysis using Hilbert Transform. Here we can see the result of instantaneous frequency estimation using HT for one bar signal without artificial leak created at the pipeline. The peak appears around 0.3701 second for outlet position. Meanwhile, for the signal with leak, the peak appears at two positions that are 0.1793 second and 0.3692 second, assumed as leak and outlet respectively. All the result in the time will be converted into distance by using equation stated above. That is, distance equal to time times by speed of sound divided by 2. The material of the pipe used a speed of sound of 524.3 meter per second. Okay, for no leak 3 bar water pressure, we can see that the peak clearly appears at 0.3495, that assumed as outlet position. While for the lead signal, the peak appears at two positions, that is 0.1887 second and 0.3618 for lead and outlet position respectively. So, table here summarizes all the results for the lead and outlet features. We can see the error between the measured distance and analyzed distance only below than 4%. So it shows success to locate the position of leak and other features along the pipeline using the method approach in this paper. As a conclusion, this research mainly focused on leak detection based on pressure transient analysis method. This method analyzed the transient signal and could be seen as an accurate and low-cost method. Leakage and outlet position determined with the error only less than 4%. Next generation of HHT, which a combination of CEEMD as a pre-processing and HT as post-processing method, shows success in detecting leakage and other features along the pipeline. Thank you. Got any question, you can ask me.